Alright guys, D9, solving rational equations. Alright, so an equation that contains one or more rational expressions is called a rational equation. One way of solving it is to find the lowest common denominator of all terms, multiply each term by it. In doing so, this will eliminate all fractions. That's essentially what's happening. A little side note, you cannot divide by 0. So that value that makes your denominator 0 is not part of your domain. So if you solve for x, and x turns out to be a value that when substituted back in results in you dividing by 0, then that value is an extraneous solution. It is not a solution. So this one, for example, x cannot be 0. If it were, you get 2 over 0, and that's bad. So if that were to happen, 0 is not a solution. For this one, x cannot be negative 1. If you were to plug that in for x, again, you would get a fraction with 0 in your denominator, and that is bad. So after you solve it for x, we want to go back in and verify it. Okay, so number 1. So this one, what happened? If you recognize the lowest common denominator, it'll save you some work. And in this case, it's going to be y plus 4 times 5, or 5y plus 20. If you don't recognize the lowest common denominator, that's fine. It'll just take a few more steps. So I'm going to go that route. So let's assume the lowest common denominator, we are not sure what it is. In that case, you want to multiply by your denominators one at a time so they all clear out. So if I multiply this one, I end up with 2 times y plus 4 over y plus 4 times this next term. So just make sure you distribute it to every term. Whatever you do to one side of the equation, do to the other. So it would look like this. From here, we can simplify quite a bit. Y squared plus 4y, so just distribute this y there. And then over here, y plus 4 over 5. Alright, in this case, we're pretty good. I mean, if you want to multiply everything by the 5, you could, so that there's no fractions. Or if you want to work with the fraction, you can. It's not a big deal. Entirely up to you. I'll go ahead and multiply by that 5, and we'll just have no fractions whatsoever. So, multiply here, it'll cancel there. Whenever you do to one side, do to the other. So we got 20y, y plus 4 is left there. 5y squared, and 10. Alright, at this point, it is an equation, a polynomial equation, and solve it any method that you have seen prior. With a quadratic in this case, with a quadratic, we want to set it equal to 0. So, I'm going to leave my leading coefficient positive, which in this case is 5y squared. So I'm going to send these terms over. Why don't you change colors? There you go. Minus y minus y, minus 4 minus 4. And what is the result? 5y squared. 20y minus y, that's 19y. And 10 minus 4 is 6. A nice quadratic here. Factor it if possible. If not, completing the square always works, as does quadratic formula. So I am going to try to factor this guy. You can do slide and divide or just guess and check. I'm going with guess and check because this is prime, so there's not a lot of options. 5y and 1y. And then we have 6 on the back end. So not a lot of options there either. 3 times 2 or 6 times 1. Let's see if we can get to it that way. Get to this 19y in the middle. 3 times 2, alright, so 3y and 10y is 13y, so it's not 19y, so that did not work. We switch it the other way, 3 and 2 that way. What do we get? 2y plus 15y to 17y, that's still not my 19y. Alright. 6 and 1 maybe? 6y, 5y is 11y, that did not work. 1 and 6, we get 30y and 1y is 31y, that did not work either. Alright, so it's not factoring nicely. So let's go back and we'll just do quadratic formula. Quadratic formula is, bring that out, negative b plus or minus square roots, b squared minus 4ac, whole thing divided by 2a. The part underneath the radical is called your discriminant, b squared minus 4ac. If we tested that out initially, if that results in a perfect square, then we should have been able to factor it. If it does not, then factoring is not ideal. So b squared take away 4ac. So that results in 241, which is not a perfect square number. So there's no square root of that. So once that occurs, then let's go ahead and run with quadratic formula. So negative b plus or minus b squared minus 4ac, which we did calculate. So it's not wasted work. Divided by 2a, which is going to be 10, because 2 times this 5 is 10. And that's your solution. We have two solutions. If we go back to the original equation, the only values we could not use, could not have for a solution, would be negative 4. Y cannot be negative 4. If that were to happen, we would divide by 0 right there, negative 4 plus 4. So since our solution did not match that, we're good. So the solution is right here. If you were to graph both sides, they would cross twice. So that's another option to check your work. So you would graph that side and graph that side, and you'll notice that it crosses it twice at the two values that you get from this expression here. One value when you add, one value when you subtract. That one's number 1. All right, number 2. So let's go ahead and identify what values we cannot have. M cannot be 4. M cannot be 2. Plug in 2, divide by 0 there. Plug in 4, you would divide by 0 there. So cannot have that. Lowest common denominator, if you would recognize it, and a lot of times it'll be just a product of your denominators. Not always, but plenty of times it will be. So whatever the product of those two are, will be the lowest common denominator. So we can multiply both sides of the equation by that. Again, if it's not obvious, and you have a fraction equal to a fraction, you just cross multiply. That times that, that times that. And I'll show you both ways and show you that why that cross multiplying works. Okay, So again, no variables in your denominator, so we'll multiply this by m minus 4, whatever you do to one side, do to the other. So 1 equals 2 times m, 2 times 4. Alright, so you got that m minus 2. So let's go ahead and multiply that out. So we end up with m minus 2 times 1, or m minus 2. Over there, it cancels, 2m minus 8. This one's linear, so let's just solve this. A quadratic, you do not have to set equal to 0. Just get m by itself. What do we get? 1m is equal to 6. There's our answer. It's not one of our excluded solutions, or values, that is. I'm going to plug it in, though. Let's just double check and make sure this works out. Let's plug in 6 and 6, which would result in 1/2 equals to 2/4, which checks out. So that works right there. So the answer is 6. Cross multiplying works, so that's what we did. Cross multiplying just shortens it out. So let's see. That. So m minus 2 times 1 is what happened. Here it is, m minus 2 times 1. When I did it on the right, it just canceled. On the second part, that was the second part, I'm sorry. On the first part, we'll multiply by m minus 4. And again, it canceled here, and it just multiplied to this other guy. So if you just cross multiply, when you have a fraction equal to a fraction, you'll get the same result if you had gone through all the steps I just went through. So m minus 2 times 1 gave me this guy. M minus 4 times 2 gave me this guy, and then we were able to solve it. So it's just a shortcut as opposed to multiplying everything by m minus 4 and then m minus 2, which the product of which is your lowest common denominator. Number 3. If you did your lowest common denominator, it will be 4 times 2 times x, which should be 8x. X cannot be 0, cannot divide by 0. But I don't think that's quite necessary. We're just going to mess with some fractions here. Nothing wrong with fractions. So we'll multiply this by x. So we do want to get rid of any variables in your denominator. So 12, 3x over 4 equals 3x over 2. And this one's linear. So let's just solve this guy. So let's see which one's bigger. 3/4, 3/2, that one's bigger. So I hate when that happens. So minus 3/4 x, whatever you do to one side, do to the other. 3/2, we need a common denominator. So let's double that and double that. 6/4 take away 3/4 is, well, 3/4. Just subtract your numerators. Alright. And to get rid of the 3/4, so isolate the x, let's multiply by 4/3. 12 is 12 over 1. So that cancels. And 48 divided by 3 is 16. 12, yep. And let's just plug that in to verify. So we plug in 16, we get 12 over 16 plus 3/4, 3/2. So this is 3/4 plus 3/4, which is 6/4, which is indeed 3/2. So 16 does check out. So number 3 is 16. So if you want to do most lowest common denominator, you could have 8x. Eliminates fractions, but it's not always necessary. So that is number 3.